Hey y'all, Miss Brown here. And this is Wednesday, September 30th. And I want to go over yesterday, Tuesday the 29th's homework assignment. And don't forget, for Tuesday the 29th in class, we also did focus notes. So using that slideshow that I went over, y'all should take your focus notes. And focus notes is located on page 9. Tells you the vocab I want you to use. Tell me kind of a quick little bit. What are you going to do? Focus notes? Are you going to do Cornell style, 3-column, 2-column, or are you going to take your own? And then you're going to upload one of those pages wherever you did your focus notes onto your never-ending slideshow. So let's go over this, page 14, which is the homework. And I'm going to show y'all on this page right here. Okay, so it says atomic structure, draw 5 protons in the nucleus of the atom, label them with their charge. So you can draw 5 little plus signs. Then 6 zeros, 6 N's for neutrons is fine. Then 2 electrons in the first energy level, because remember the first shell holds 2. And then if it only has 5 protons, that means it has 5 electrons. So if it has 5, 2 go in the first shell, that leaves 3 for the second shell. So you should have 3 in that second shell. What element is represented? If the atomic number or the number of protons is 5, that means the atomic number is 5, which means that I go and look on my periodic table, and I know that it is boron because boron's atomic number is 5. So I'm going to write that that is boron. So label the information provided on the table. Number 8 is the atomic number, O is the symbol, oxygen is the element's name, and 15.999 is the atomic mass that rounds to 16 for the mass number. The atomic number represents the number of protons and the number of electrons. And the atomic mass technically represents, y'all, the number of protons plus the number of neutrons. Because remember, to find the number of neutrons, you take this atomic mass, round it, and subtract the atomic number from it. So if the atomic number is protons, then technically the atomic mass represents the number of protons and the number of neutrons. So how do you figure out protons? You look at the atomic number, and then the atomic number is the protons, and it's the same as the electrons. So nitrogen's atomic number is 7, so it has 7 protons and 7 electrons. How do you find the number of neutrons? So it's 8 man, M-A-N, mass number minus atomic number equals the number of neutrons. So test your knowledge by doing this in the chart. Let's see how I do, y'all, because I don't even have my thing with me. So atomic number is 3, which means it has 3 protons and 3 electrons. And if its atomic mass is 7, 7 minus 3 is 4, so it has 4 neutrons. P is phosphorus. If phosphorus's atomic number is 15, that means it has 15 protons and 15 electrons. And then to find neutrons, you take 31, atomic mass rounded, and you subtract 15 from it. So that would be 16, so it would have 16 neutrons. Cl is chlorine. So if chlorine's atomic mass is 35 and its protons is 7, that tells me that its 17. That tells me that its atomic number is also 17. So 17 atomic number, 17 protons, 17 electrons. Y'all, this column, atomic number, protons, and electrons should all be the same number. So 17, 17, 17, and then whatever 35 minus 17 is, 17, 27, 37, so 18. So it would have 18 neutrons. Ni is nickel. So if nickel's atomic number is 28, that means it has 28 protons and 28 electrons. Now to find atomic mass, remember y'all, I take the protons plus the neutrons. So 28 plus 31 is 59. So its atomic mass would be 59. And I'm curious, let me see if I go to nickel. Nickel's atomic number is 28. So right here, and 58.6 rounds to 59, which is perfect, y'all. K is actually potassium, because in Latin, all the periodic table element symbols were first formed in Latin, the Latin language. And potassium in Latin is kalium, K-A-L-I-U-M, which is why the symbol's K. So if its atomic mass is 39 and its electrons is 19, remember, if its electrons is 19, its protons is 19, and its atomic number is 19. So it has 19 atomic number, 19 protons, 19 electrons, and to find the number of neutrons, you take these 2 columns and subtract. So 39, yeah, So 39 minus 19 is 20, so it would have 20 neutrons. Ag is actually silver, y'all, aguila. So in Latin, silver is aguila, which actually means swan, which is kind of cool because swans have this like kind of white, silvery kind of feathers. So silver's atomic number is 47, which means it has 47 protons, 47 electrons. And if it has 47 protons, y'all, and 61 neutrons, then that means that you take the 61 neutrons plus the 47 atomic number to get the atomic mass. So 60 plus 40 is 100, 7 plus 1 is 8, so 108 would be the atomic mass. H is hydrogen. So hydrogen atomic number is 1, because its protons is 1, so its electrons is 1. If its atomic mass is 1, y'all, you do atomic mass minus the atomic number. So 1 minus 1 is 0. Hydrogen is the only element that has 0 neutrons. Si is silicon. So if silicon's electrons is 14, that means its protons is 14, which means its atomic number is 14. So its atomic mass, remember, its atomic mass is the number of protons and neutrons. So if it has 14 and 14, then the atomic mass is 28. Y'all, W is tungsten. So tungsten's proton is 74, which means its atomic number is 74, which means its electrons is 74. And then to find its atomic mass, it's protons and neutrons together. So 74 plus 110 is 184. And then Ne is neon. So neon's electrons is 10, which means its protons is 10, which means its atomic number is 10. If it has 10 neutrons and 10 protons, then 10 plus 10 is 20, so its atomic mass is 20. Y'all, I'm pretty impressed with my quick math skills, I'm not even gonna lie. So make sure you add page 14 to your never-ending slideshow. So this is Wednesday the 30th, but I was reviewing last night's homework. So now let's get into the work for Wednesday. So y'all, Wednesday we talked about the difference between ions and isotopes. So an ion is when you have an element or an atom that has gained or lost electrons. So an ion is not a typical atom because remember, atoms typically have a 0 charge. Because if you have 3 plus electron, 3 minus 3 plus proton, 3 minus electron, 3 plus, 3 minus, bing, 0. So an ion is when you have a charged atom because you've either gained electrons, which is actually going to make you negative charge. Why? What charge are electrons? Negative. So people think in their head, just because you gain something, it means you're positive. Well, that's not true. If you're gaining something that's negative, you're gaining that negative energy. So you're going to be negative, y'all. So gaining electrons actually makes you negatively charged. And losing electrons actually makes you positively charged because you're stuck with an extra proton. Versus an isotope is when you have a different number of neutrons. So isotopes have the same protons, same electrons, still 0 charge, but they have different neutrons. So for example, nitrogen is supposed to have 777, heavenly number. And if nitrogen has 8 neutrons or 6 neutrons, it's going to be an isotope. That doesn't affect the charge because neutrons are neutral. So y'all are going to watch this little video. I'm not going to play it for you. You guys can watch it on your own to get a little more background about the difference between ions and isotopes. So y'all, I'm going to see if I can open up my trash slides. That's what I call them, y'all, because it's just slides that I use that I don't really put anywhere. So I'm going to see if I can do scribble. I don't know if it will let me do more than one scribble at a time. So if I have scribble. Yeah, I'm trying to figure out how I can draw on this easy, but I don't think that there's a way. So let me go to Insert, Image, search the web. Plus sign. Just because y'all, I like to, we'll do this green one, I like it. Okay, and then I'm gonna search minus sign. And I'll do this red one. I don't know if that has both together. I'll do this black one. Perfect. There you go. Okay, y'all. So if I have 1 plus and 1 minus, what is my charge going to be? 0 or neutral. Why? Because a plus and a minus cancel out. But now, what happens if I have 3 plus signs? How many minus or how many electrons should I have? I should have 3. So if I have 3 protons like lithium, I should have 3 electrons. This would be a neutral atom. Lithium has 4 neutrons. So I'm going to go to Insert, Image, and I'm just going to put, oh, nope, Insert, Image, Search Web. I'm going to just put the letter N and see if I can just get a letter N. Oh, this is perfect, y'all. So I'll do this as my neutron. So lithium has 4 neutrons because its atomic mass is around 7. So it has 4 neutrons. So this is what lithium looks like. This is a typical lithium atom. So I'm going to label it lithium. So lithium's atomic number is 3, which means it has 3 protons, 3 electrons, and 4 neutrons because its atomic mass is 7. So 7 minus 3 is 4. Now, if I have a lithium ion, remember ion is plus or minus electrons. So let's say I get rid of one of these electrons. What do I have for my charge? What do I have for my charge, y'all? It's like Dora the Explorer. What do I have for my charge? No, I don't like that my scribble is not what I want. So there we go. So those cancel out. And these cancel out. And that leaves me with 1 extra proton. So my charge would be what? What would my charge be? My charge is actually going to be +1 because I have 1 extra proton. And what's proton's charge? Positive. So I write Li +1 because lithium symbol is Li. Now, what happens if, and I'm going to move this here, and I'm going to kind of leave this here, y'all, in case you want to do a screenshot. So that way you have it as an example. Now, I'm actually going to duplicate this slide, y'all. Thinking on my feet here. So now I'm going to go to this one. And now what I'm going to do is I am going to add my electron back. And now I'm going to add another electron. So I'm going to add 1 more electron right here. So what I'm going to have is, now these are going to cancel out, my 3 and 3, and now I'm left with 1 extra negative. So what does that mean for my charge if I have an extra electron and electrons are negatively charged? I'll give you all a minute to think about that. Neutrons don't have any effect, y'all, so those ones are good. I'm actually going to make these a little bit smaller. We'll kind of stack those up. So what's my charge going to be, y'all, if I have an extra electron? Yes, it's going to be negative, right? Because I have an extra negative. So then instead of lithium +1, I'm going to have lithium -1, which is going to be my ionic charge. Now, it is possible to have more than 1 gained electron. So it is totally possible that I could have 2 extra electrons. And if I have 2 extra electrons, what's my charge going to be, y'all? That's right, -2 because I have 2 extra electrons. And then similarly so, it is also possible to have lost more than 1 electron. So if I'm here and I lost this other electron, then this doesn't cancel out anymore. And now I have 2 extra protons, which would make my charge what? +2. So if you are gaining extra electrons, it is going to make you negative because you are gaining negative charges. If you are losing electrons, you're losing a negative charge, so you're left over with a positive, so that would make you have a positive ion. Rock on, let's talk about isotopes, y'all. So isotopes are a lot easier. So an isotope is when you have a different number of neutrons. And this is how I remember, y'all, and I know it's silly. Isotope, 7 letters, and Neutron, 7 letters. So I remember that neutrons and isotopes go together. So an isotope is a different number of neutrons because proton is only 6 letters and electron, electron, is 8 letters. So those don't match up. So in my head, I remember neutrons, isotopes. So that leaves ion to be the other one. And y'all, I know this is silly, but this is how I remember what an ion is. And like I said, y'all, I know that it doesn't, some people, like I say this and they look at me like, what are you talking about, Miss Brown? So here is what I remember when I think of ions. So the I to me kind of looks like a plus sign. So I think of this I as a plus sign. And then I think of the letter O. Think of the letter O as the word or. So then, so I think of the letter O as the word or. So OR. And then I think of the letter N as the word negative. So I remember that an ion is either plus or negative, and you can't change the number of protons. Why? Because it's the element's identity, it's its fingerprint. So the only thing you can change is electrons, and gaining or losing electrons is going to make your charge positive or negative. So isotope, neutron, 7 and 7. An isotope, y'all, is just a different number of neutrons. So what y'all had to do was you had to, this is old, y'all. So you guys had to watch that quick video. Move my evil twin. Watch that quick video and then complete these elaborate stations. So page 15, all about ions. Page 16, all about isotopes. And then page 17, all about electron arrangement. Remember, 2 in the first shell, 8 in the second shell. So Wednesday, elaborate tutorial was that video that we just watched, or you will watch on your own. And then this elaborate discussion is stations 5, 6, and 7. So that's what y'all are going to do. Stations 5, 6, 7. I was on the right page, y'all. I got confused. And then you're going to work on these stations in your journal. Take pictures, add it to your never-ending slideshow. I'll go over this at a later date. And then the last thing that I want y'all to do is this quick discussion post. Notice how this is a discussion post. So here you're going to pick 2 of these 4 questions and you're going to answer them below in the discussion post. So just hit, I don't want to go too far so when you see the answers, just hit reply and then restate the question. You can answer them both in the same post. That's fine for me. So this was Wednesday, September 30th, y'all. Have the best day ever. Love each and every one of you. And you fill my buckets each and every day. Overflowing. Bye, y'all.